The moment your hand reaches into a bag of salty chips, your brain is not suffering from a lack of willpower. Your kidneys have just fired a high-speed chemical flare straight into your brainstem because your vascular fluid pressure dipped by less than 2%. Right now, microscopic pressure sensors inside your kidney filters are measuring the hydraulic stretch of your blood vessels with the accuracy of an atomic clock. When that stretch slacks off even slightly, your internal biochemistry instantly rewires your appetite, turning a simple mineral into an irresistible survival imperative. You are about to discover the renin-angiotensin-aldosterone system, an extraordinary, automated pressure monitoring circuit inside your body that links your kidney filtration units directly to your brain's deep motivation centers. Think about what happens on a typical afternoon. You are sitting at your desk, working through tasks, and suddenly, out of nowhere, a relentless, highly specific craving strikes. You do not want an apple. You do not want a spoonful of honey. You crave something crunchy, intensely savory, and covered in salt. Most people assume this is a psychological failing or a simple habit, but if you could zoom inside your lower abdomen right now, you would see a biological control room operating with absolute precision. Your circulatory system is essentially an endless network of flexible plumbing pipes. For oxygen and nutrients to cross out of your blood vessels and nourish your cells, the fluid pushing against those vessel walls must remain at a very tight pressure baseline. Right now, if blood pressure drops even a fraction below that baseline, your cells begin to starve of immediate gas exchange. To prevent this, your body relies on specialized structures located inside your kidneys called juxtaglomerular apparatuses. Imagine these apparatuses as microscopic pressure-sensing cuffs wrapped tightly around the microscopic blood vessels entering your kidney filters. When your overall blood volume decreases, whether from mild dehydration, sitting motionless for hours, sweating, or hormonal shifts, the blood vessel wall loses a tiny fraction of its natural stretch. The juxtaglomerular cells detect this loss of tension instantly. They do not wait for permission from your conscious mind. Within seconds, they release a specialized enzyme called renin directly into your bloodstream. Once renin enters circulation, it acts like a molecular pair of scissors. It travels to your liver and snips a circulating protein called angiotensinogen, transforming it into angiotensin 1. As angiotensin 1 floats through your lungs and blood vessels, another enzyme converts it into angiotensin 2. Angiotensin 2 is one of the most potent vessel-constricting chemicals known to biological science. It immediately commands your peripheral arteries to squeeze tighter, instantly raising pressure inside the pipes. But tightening the pipes is only a temporary patch. Your body needs more physical volume inside the system. To solve the volume problem, angiotensin 2 crosses into specialized regions of your brain that lack a strict blood-brain barrier, specifically an area called the subfornical organ. At the exact same time, it triggers your adrenal glands to release a hormone called aldosterone. In a landmark scientific study published in 2008 by Dr. Joel Geerling and Dr. Arthur Lowy, researchers mapped the precise neural architecture in the hindbrain that responds to this combined hormone signal. They discovered a dedicated group of neurons in the nucleus of the solitary tract that possess dual receptors for both aldosterone and sodium signals. When these specific neurons switch on, they selectively rewrite your neural taste perception. By the way, if you are finding this internal pressure mechanism as mind-blowing as I do, take a brief moment right now to subscribe to Body Decoded and leave a comment below sharing what time of day your salt cravings usually strike. Sharing these specific biological insights tells the platform that deep body science matters, which helps this channel keep decoding what is really happening inside your tissues every single day. Now, let us look right back at what happens in your brain the second those specialized neurons ignite. Suddenly, the thought of salt changes from neutral to overwhelmingly rewarding. Your brain's dopamine pathways light up in response to sodium chloride, making salty food taste exponentially more intense and satisfying than it would if your blood pressure were balanced. Your intense desire for chips is actually your brain executing a survival maneuver to draw water back into your bloodstream. When you consume sodium, it enters your intestinal tract and is rapidly absorbed into your vascular system. Sodium acts like a powerful sponge, Through the basic law of osmosis, water rushes out of surrounding tissues and into your blood vessels to balance the high salt concentration. More water inside the vessels means greater blood volume, higher hydraulic pressure, increased stretch on the vessel walls, and proper oxygen delivery restored to every tissue in your body. But here's where modern daily life creates a profound biological mismatch. What happens when this ancient evolutionary emergency system gets continuously tricked by modern environments? This is the high-energy reality of what is happening inside you every single afternoon. In our evolutionary past, a drop in fluid volume usually meant acute blood loss, severe heat exhaustion, or prolonged physical exertion. Today, however, millions of people trigger this exact same low-pressure emergency signal simply by sitting still in a chair for 5 hours straight. When you remain seated for long periods without moving your lower body, gravity pulls a significant percentage of your blood downward into the deep veins of your thighs and calves. This is known as venous pooling. The blood is physically trapped in your lower extremities because you are not contracting your leg muscles to pump it back upward against gravity. Because that blood is sitting stagnant in your lower limbs, less blood returns to your heart, and crucially, less blood flows through your kidney filters. Your juxtaglomerular apparatus does not know you are just sitting at an office desk. It only knows that vessel stretch has dropped dramatically. It panics. It releases renin, generates angiotensin II, triggers aldosterone, and sends an urgent neurochemical signal to your brain saying, "Eat sodium immediately, or your circulation will fail." So you walk to the kitchen and consume a high-sodium, ultra-processed snack. You feel an instant wave of biochemical relief because your brain rewards you for answering its SOS. But because you are still sitting down, the fluid you just pulled into your bloodstream eventually trickles right back down into your lower legs, pooling once again. You have created an artificial biological feedback loop where your physical posture constantly misleads your kidney sensors into requesting more sodium than your body actually needs. In a seminal cardiovascular study published in 1976 by Dr. Edward Fries, scientists demonstrated how altering fluid dynamics and vascular stretch fundamentally dictates systemic pressure regulation and neural feedback loops. When total volume and vessel stretch are continually mismanaged through static posture and improper hydration, your internal pressure set point becomes chronically unstable. Consider another modern trap: drinking massive quantities of plain, pure water while sitting completely still. You might think drinking 2 liters of water midday is helping your body, right? But if that water lacks natural mineral electrolytes, it quickly dilutes the sodium concentration in your blood plasma. Your kidneys respond to this sudden loss of osmotic balance by dumping excess fluid through urine to protect your cells from swelling. The paradox is stunning. You drink plain water to hydrate, your body flushes it out to balance sodium levels, your overall vascular volume drops again, and your kidney baroreceptors fire off another frantic salt craving. You are caught in a hidden biological tug-of-war between fluid volume, mineral balance, and gravity. But once you understand the actual mechanical sequence operating inside your body, you can stop fighting your biology and start working directly with it. Here are 3 precise, scientifically grounded habits you can use to calibrate your body's vascular pressure system and handle salt cravings with total accuracy. First, implement the postural hydro reset every 45 minutes. Because venous pooling in the lower legs is a primary trigger for false low-pressure signals, you must regularly engage your peripheral heart. Your calf muscles contain deep venous sinuses that act as a mechanical pump. Every 45 minutes, stand up and perform 20 slow calf raises, rising up onto your toes and squeezing the back of your lower legs. This mechanical compression physically drives pooled venous blood back up into central circulation, restoring stretch to your renal blood vessels. Within 2 minutes, your juxtaglomerular cells register the restored stretch and dramatically turn down renin secretion, shutting off false salt cravings at their vascular source. Second, adopt the strategic mineral prehydration strategy. Instead of chugging large quantities of plain, distilled, or heavily filtered water on an empty stomach when cravings hit, combine your water with tiny amounts of natural, unrefined mineral balance. Adding a small squeeze of fresh lemon juice and a microscopic pinch of unrefined sea salt to your water introduces trace minerals alongside fluid. This creates an isotonic balance, allowing the water to easily enter your blood vessels and interstitial spaces without diluting your plasma sodium levels. Your vascular volume remains stable, your vessel stretch stays constant, and your brain never receives the neurochemical signal that it needs to hunt down high-calorie processed chips. Third, utilize potassium-rich vascular counterbalancing when eating savory foods. When you do experience a genuine physiological salt drive, pair that sodium intake with whole food sources rich in potassium, such as dark leafy greens, avocado, or celery. Potassium acts on the distal convoluted tubules of your kidney nephrons, working directly against aldosterone by promoting healthy sodium excretion once volume balance is restored. This prevents the high sodium intake from lingering too long in circulation and causing unwanted arterial stiffness, allowing your kidneys to clean up excess mineral loads smoothly and efficiently. Take a moment to pause and absorb what this really means. You are not a broken organism with uncontrollable dietary urges. Your body is an extraordinarily complex, self-regulating biological system that uses neurochemical impulses, hormone cascades, and appetite shifts to keep your vascular pressure within a precise physiological window. When you feel that intense urge for a salty snack, it is not a moral failing or a lack of self-discipline. It is a sophisticated survival signal sent from your kidney baroreceptors straight to your brainstem. You are not at the mercy of your cravings. You are simply reading the internal operating manual of your own vascular system in real time. Now, ask yourself this simple question. Do your salt cravings usually strike while sitting at your desk? If this deep dive into your body's pressure machinery shifted how you look at your own biological signals, go ahead and like this video right now as a practical bookmark so you can easily return to this explanation whenever your body signals a salt craving in the future. Understanding how your blood vessels, kidneys, and brain communicate is only the beginning of taking full command of your daily biological health. Right now, in our research lab, we are uncovering another astonishing hidden molecular communication loop happening inside your tissues every single hour without you even realizing it. And trust me, what we are discovering about how your internal organs continuously re-engineer your energy levels will completely transform how you go through your day. Subscribe to Body Decoded right now so you do not miss this next groundbreaking discovery the moment it drops.